Welcome. In this video, we are going to determine the fraction of gold fillings from a mixture of gold and brass. So we have the question that says a 50 grams copper cup that is insulated from its surroundings contains 125 grams of water at 20.5 degrees Celsius. A 310 grams mixture of brass and gold fillings at 150 degrees Celsius is placed into the water. It is found that at equilibrium, a temperature of 42.3 degrees Celsius results. What fraction of the fillings is gold? So this is the question that we're going to find, or rather, this is what we're going to, this is our goal will be to find, or rather to determine the fraction of the gold fillings. So from this, we have been taught to take the specific heat capacity of gold to be 0.031 calories per gram per degree Celsius, and the specific heat capacity of brass is 0.090 calories per gram per degree Celsius. Then from here, so the data that we have is the mass of copper cup, that is 50 grams at 20.5 degrees Celsius. Then mass of water is 125 grams at the same initial temperature, 20.5. Then the final temperature is 42.3 degrees Celsius. Then the mixture, which is 310 grams, is at 150 degrees Celsius. The specific heat capacity of gold as given is 0.031 calories per gram per degree Celsius. Then the specific heat capacity of brass is 0.090 calories per gram per degree Celsius. Now the other standard values that we have is the specific heat capacity of water, which is 1 calorie per gram per degree Celsius, and then the specific heat capacity of copper is 0.092 calories per gram per Celsius. Okay, so now from here we're going to proceed as follows. Our goal is to determine the fraction of the gold filling. So the solution, we have the mixture of mass, which is the mixture, the mass of mixture, so to say, which is 310 grams. That is, if we add the mass of brass and the mass of gold fillings, we must get a 310. So from here, we say MB plus MG is equal to 310. So from here, we are going to add this. So if we make MB the subject, which is the mass of brass, the subject of the formula, we are going to have MB is equal to 310 minus mg. So we call this equation number 1. Now, according to the principle of energy conservation, we have the summation of the energies must be equal to 0. So what we're going to do is we're going to add the heat that is going to result as the mixture is poured into the copper cup that contains water. So the heat that is going to be gained by the copper cup and the water must be equal to the energy that is going to be lost by the mixture, which is at a higher temperature of 150 degrees Celsius. So from this, we're going to write the Q sum, which is the total sum of the energies, must be equal to 0. So the energy due to copper, water, brass, gold, these must be equal to 0. So, but we know that an expression for finding the energy, the heat energy, is Q, which is equal to MC delta T, where the M is the Q is the heat capacity, and the M is the mass, C is the specific heat capacity, and delta T is the change in temperature, which is given by the T final minus T initial. Then writing expressions for each, we're going to have the mass of copper times specific heat capacity of copper times the change in temperature plus the mass of water, specific capacity of water times the change in temperature, plus the mass of brass times specific capacity of brass times the change in temperature, plus the mass of gold times specific capacity of gold times the change in temperature, and these must give us 0. So now, from here, we know that both the copper cup and water are at 20.5 degrees Celsius and the mixture is at 150 degrees Celsius, respectively. So if we plug in the values now, if we plug in the values from here, what we're going to have is we plug in the mass for copper, which is 50 times 50 grams times 0.092, which is the mass for, or the specific capacity of copper, which is 0.092 calories per gram per degree Celsius. Okay, that must be per degree Celsius here. Then we also have the mass of water, which is 125 times 1. This is the specific heat capacity of water. This is the mass of water. Then the change in temperature, which is the T final, which is 42 minus 20.5 in degrees Celsius. Then plus the mass of brass times the specific heat capacity of brass, plus the mass of gold times the specific heat capacity of gold, then the change in temperature. These must give us a 0. So if we multiply this, what we're going to have is we're going to have 129.6 times the change in temperature, which is 21.8 gram calorie per gram per Celsius. So plus this one, the specific heat capacity of brass, plus the specific heat capacity of this one. If we evaluate from the beginning, what we're going to have is, okay, this then times the change in temperature. These are at the same temperature, so this one and this one are going to have the same change in temperature, which is negative 107.7 degrees Celsius. So from here, it is just a matter of punching on a calculator, and what we're going to have is, for this, we're going to have this value, and then for the next part we have this value, and for the next one it is this, then we equate to 0. So from here, what we're going to have is we're going to have this value, and then if these cross the equal sign when they come this side, we are going to have a positive 9.693 calories per gram. That is the times the mass of brass, then times or plus 3.339 calories per gram. That is then times the mass of gold. So from here, we proceed now to the final, okay, as we approach the final answer now. So we need to cancel the common parameters, and if we cancel the common parameters, we are going to have 28.28 grams is equal to 9. So this one, we have this, and then we have this, and we have this. So this is our equation 2. So if we want to remain with the MB and what, so this one, this gram is coming from this. So if we multiply by G throughout, this is what we are going to get here. So if we place now equation 1 into equation number 2, what we're going to have is 2825.28 is equal to 9.69. Then in brackets 310 minus mg plus, that we close the brackets, then plus 3.339 mg. So from here we just need now to make mg the subject, and if we make mg the subject of the formula, what we're going to have is this one in terms of this. So if we divide this one 6 point, okay, so if we find this if we add, what we're going to have is negative 6.53 or 35 mg. Then this one, it will be subtracted from the one that was on the left hand side, and what we're going to get when we subtract this is negative 179.55. This will give us is equal to, so negative this is equal to negative 6.35. So if we divide through by this, we are going to have the mass of gold filling is going to be fillings is going to be 28.27 grams, and the mass of brass is going to be, that is just the 310 minus this, and what we're going to get is this. Now, since we want the fraction of gold fillings, we are going to say the fraction of gold fillings is equal to the mass of gold fillings over the total mass here. So we just need to, so if we round off 28.37, we are going to have 28 divided by 310, which is going to give us 14 over 155. Thank you so much for watching the video, and please don't forget to subscribe.